right, let's get into the mechanics of matrix matrix multiplication. And I'll start with the standard view. We're going to go through several views of this. If you think you already know matrix multiplication, this is probably what you know. I'm multiplying A times B like this. A is M by N. B must be N by something else. I'll say N by P. And these little shaded things kind of show you the standard way, which is called rows into columns. Here's, if you break down what every element of the resulting product is, each one of these little computations is the same as a dot product. So this 1 term is the first row of A times the first column of B. This 1 term is the first row of A times the second column of B, as like a dot product. Here it is with numbers. Say here's your A and here's your B. First, we can look at, are they even compatible? A is 2 by 3. B is 3 by 2. I'll write those out as the inner numbers match, 3 versus 3. And the resulting product will be 2 by 2. Okay, we know that much. So let's see. The resulting product, I'll do 315 times 263, or 6 plus 6 plus 15. Sorry, this is kind of bad arithmetic. I get too many higher numbers. Let's see, what do I get over here? I get 3 times minus 5 plus 1 times 1 plus 5 times 8. Kind of bad arithmetic, you get 20. Anyway, that's how you do rows into columns. You can do this thing, a 1 by 2 and a 2 by 1. That'll just be 3 plus 8. 1 by 1 result is 11. This also works. A 2 by 1 and a 1 by 2, compatible size, you'll end up with a 2 by 2. Top left will be 1 times 3, top right will be 1 times 4, etc. That standard method you probably already know. Let's look at this guy again. Let's pick a row of C. Let's pick the second row of C. Look at this first subscript for the A's. It's all A sub 2 something. That means the only A's that show up in the second row of C are A's from the second row of A. All these other rows have no effect on that particular row of the outcome. And if you look at columns, it's similar with the B. Take this second column of C. All the second subscripts of the B's are 2. So that second column only comes from the second row of B. The second column of B. The other columns of B do not affect the second column of the resulting C. So sometimes you can just see things without having to like multiply it out and think it through. Let's say I pick a certain row of A and make one guy 1 and the rest guys 0s. I know in this case I did it in the first row. That's only going to affect the first row of C. And the 1 in the first position is going to pick off the top elements of the B's. So I'm just going to end up here with B11, B12, out to B1P. If I put this row somewhere down here, it would put this row somewhere down here on C. And if I move the 1 to some other place, it just picks up a different row of B. Up here, it picked off the first row of B. It's kind of hard to see these things the first time through. And I can't even say I'm like really slick at it. Gilbert Strang is slick at it. I'll get into other views of this, which is probably something you probably haven't seen, unless you've already taken a linear algebra course. Many multiple views of matrix multiplication. Say that for another video.